max sublayer in LANs. The access method is TDMA, time division multiple access. The primary and secondary stations communicate with each other using time slots. The length of the time slot is exactly the same as the dwell time, 625 microseconds. This means that during the time that one frequency is used, a primary sends a frame to a secondary, or a secondary sends a frame to the primary. Note that the communication is only between the primary and the secondary. Secondaries cannot communicate directly with one another. What about TDMA? Bluetooth uses the form of TDMA that is called time division duplex TDMA. TDMA is a kind of half duplex communication in which the sender and receiver send and receive data but not at the same time. So this is called half duplex. However, the communication for each direction uses different hops. This is similar to walkie-talkies using different carrier frequencies. Single secondary communication. If the piconet has only one secondary, the TDMA operation is very simple. The time is divided into slots of 625 microseconds. The primary uses even numbered slots 0, 2, 4 and so on, and the secondary uses odd number slots 1, 3, 5 and so on. The TDMA allows the primary and secondary to communicate in half duplex mode. In slot 0, the primary sends and the secondary receives. In slot 1, the secondary sends and the primary receives. The cycle is repeated. Okay. So this is how it works. Okay. So primary, secondary, and they send information alternatively with the proper header and the data modules. What about multiple secondary communication? The process is a little more involved if there is more than one secondary in the piconet. Again, the primary uses the even numbered slots, but the secondary sends in the next odd numbered slot if the packet in the previous slot was addressed to it. All secondaries listen on even numbered slots, but only one secondary sends an odd numbered slot. So primary sends it, and whichever secondary it is intended to reply back replies, and again this primary sends it, both the secondaries receive it, but if it is the intended recipient, then it replies back. So this is how it happens in the multiple secondary communication. Now this explanation about the figure where it is addressed to secondary 1 or secondary 2. So other thing remains silent. So this cycle continues. We can say that this access method is similar to pole select operation with reservations. When the primary selects a secondary, it also polls it. The next time slot is reserved for the polled station to send its frame. If the polled secondary has no frame to send, the channel is silent. What about links? Two types of links can be created between primary and secondary: SEO links and ACL links. What are these? So synchronous connection oriented link is used when avoiding latency is more important than integrity. So we should be fast. We don't worry about it, is error free. So fast communication is important, then synchronous connection oriented link is used. In an SEO link, a physical link is created between the primary and the secondary by reserving specific slots at regular intervals. The basic unit of connection is 2 slots, one for each direction. If a packet is damaged, it is never retransmitted. SEO is used for real-time audio where avoiding delay is all important. ACL, asynchronous connectionless link, is used when data integrity is more important than avoiding latency. In this type of link, if a payload encapsulated in the frame is corrupted, it is retransmitted. A secondary returns an ACL frame in available odd numbered slot if the previous slot has been addressed to it. So here data is so important, so it is being retransmitted in case there was